Yes, hi guys. Now today I want to just talk about some more special type of integrals, okay, in which we have to integrate them with the help of bypass method. But in case of bypass method, now these are the some special functions which I have just to talk about, and after that I'll solve these questions which are based on the same type of special type of functions. Now special functions are these three. I have to talk about first A, B, and C. Okay, these are the three which I have to talk about. These are some special type of functions. Now, third type of functions are in which there are some integrals are given which we have to break into two parts. Okay, and one of them is to be integrated with the help of bypass method. Then the other one will be cancelled out, which by the result which we will obtain from the integral of the first one. Okay, so I mean the two integrals of after breaking this and integrating it by parts will be cancelled out. So that kind of questions are also there. So today's integrals are very important. They should also be known to the students. Otherwise, the possibility of getting mastery of the subject will not be obtained. Okay, so that is one of the points required. Now let me talk about the integrals, that is special kind of integrals. These integrals we have already done the first two questions, which are of two special type of functions which we have already done, but not by the bypass method. Now today I have to talk about these two questions, okay, and other questions are also of the same type, which are to be done with the help of bypass method. And then the third type, which are there are integrals given which we have to break into two parts, and one of them is to be integrated with the help of bypass method. Then the second one will be cancelled out by the result of this first integral which be integrated with the help of bypass method. That is the third process. That kind of questions are also there. These questions, as I always say, that I have selected from the students' queries in the classroom as well as by online students. Mostly online students, they have asked me these questions. So let me solve these questions, okay, so that verification can come. Now let me take the first special type of, so some special integrals which are to be integrated with the help of, or integrals of them are to be found out with the help of bypass method. With the help of bypass method. Bypass method. Okay, so these are some special integrals. Let me talk about them. So first one is the first type, that integral of what is x square plus a square, or a square plus x square into dx. So this we have already done in case of hyperbolic functions. In that case also we discussed about these questions. Now today I will talk about that with the help of bypass method also we can integrate. So in this case there is only a single function. We have to consider that there is multiplication of one also. One integration by a square plus x square minus sign. Now deviance of this will be first half power will come before, because this is half power. Now the leftover power is minus half, because half minus 1 in case of differentiation. Okay. That will be minus half leftover into differentiation of the inner value. A square is 0, x square is twice x. Okay, into x, this x. Okay, now into dx. Now let us solve it. X under root a square plus x square minus sign half. Okay, now this is sign of integration. 2 to cancel out. 2 and 2 cancel out. Let me remove this 2. Is removed. The sign of integration is will be x square upon a square plus x square half square root a square plus x square. Why? Because this is minus half over, and in the denominator will be positive, so it will be the square root of a square plus x square into dx. Why this x square? Because x is this and this x is of 1 integration of 1, that is x square. Now if I solve it by adding something and subtracting something here, let me add something, x square plus a square and minus a square, no change, divided by under root a square plus x into dx. So what will be the next step? With x under root a square plus x square minus sign. Now the first step will be, if I divide this x plus a square by this, we will get sign of integration only x square plus a square or a square plus x square, because this is 1 power, this is half power, and half power will come in the numerator, or 1 minus half, that means half power left over. This is I separated. Then minus minus plus here is plus sign a square, sign of integration. This is 1 upon under root a square plus x square into dx. Okay, but this is what this is. I know that sign hyperbolic inverse x upon a, this value is, but we will write it in logarithm form. A square into log of x plus under root a square plus x square. This is the value of this below, but this is the same value which we started with. This can be taken as I, which will be twice I, that this is I. So I is equal to this, or we are talking about I. So this is twice I now. This we have taken to this side. So this I plus I, this is twice I. So this twice I is equal to, I'm sorry, not yet. This is still twice I, let me take. This is equal to x under root a square plus x square minus sign, sorry, plus sign. This is a square. Now integration of this is log of x plus under root a square plus x square. Or in other words, we could write it as sine hyperbolic inverse x upon a, x upon a. Why? Because this is sine hyperbolic inverse x upon a, and that value is also written in logarithm form. This is log of this value. This we have already proved. Okay, so or we could write it as a square into sine hyperbolic inverse x upon a. This is that was that. Okay, so this is the answer. What is I finally? Therefore, this implies that I is equal to twice. If I divide 1.3, let me take common, x under root a square plus x square, okay, plus sign, this is a square, log of, within bracket, x plus under root a square plus x square. Okay, so this is plus constant, let me take c1 now, because after 1.2 multiplication by or dividing by 2, you get value of I. I means this value. The final answer is this is the answer. This is question number 1 as well. This is one of the special type of function which we already dealt with, but now in this case we have applied the bypass method. Bypass method also same as it is already. Okay. This is your question number first. First question we have done. This is also known as special type of integral, which is to be integrated with the help of bypass method. Now let us talk about second question or second important integral, which is sign of integration under root x square minus a square into dx. Again, this is one function, I mean single function. We have to multiply this by one or consider one as second function, just to integrate this by bypass method. So integrating it by using bypass method or BP method, okay, let us take unity or 1 as the second function, of it. Okay, so let's integrate this. So this is sign of integration. This is first function, x square minus 1 minus a square into 1 into dx. Okay, now let us integrate this. 1 is for, this is second function, this is first function, this is second function. Okay, so now integrating this on the root x square minus a square as it is. Integration of x is, sorry, let me write minus sign. This is ddx of under root x square minus a square into integral of 1 into dx whole dx. This is the value we have written down here. Okay, now let us solve it. This is x, so x under root x square minus a square minus sign. Now this is ddx of this. It will be 1.2 into x square minus a square minus half power into twice x. Why? Because integral, the value of bracket will be differentiated again, or this is by chain rule or by function of the function method. Okay, this is function of x, so it is to be differentiated again. X square is twice x, a square is 0, differentiation. So only twice x, it is 2 to cancel out into x, integration of this 1 into dx. What do we get here? Similarly, x square minus a square minus sign 2 to cancel out. So this is nothing but x square, x into x square upon under root x square minus a square into dx. Okay, so again, if this is equal to I, so I we are calculating here. So this is I equal to, therefore I means integral. This given integral is equal to x under root, this is x square minus a square minus sign. Now this can be, we can subtract a square because in the denominator we have a square, x square minus a square plus a square also. We can do divided by the root x square minus a square. This is x square minus a square. Okay, so why it was, okay, that was minus sign, no problem. So this is minus sign into dx, that is separate them. This is x and the root x square minus a square minus sign. It will be under root x square minus a square into dx, that means separate, plus, sorry, minus sign. So this is plus sign, this is minus sign, it will be still minus sign. Okay, so sign of integration. This is a square, sorry, let me write a square into 1 upon under root x square minus a square into dx. Now this integral is of cos hyperbolic inverse x upon a, but this is x square minus a square. X square minus a square is in case of cos hyperbolic inverse x upon a. But this can be written in the same way as we wrote down in the previous question, log of x plus under root x square minus a square. That will be the answer. Now this is the same function we started from this is minus I. So we can take this I to this side, this will be twice I. This is I and root x square minus a square, same function which we started with. This will be taken to this side, it will be twice I then. equal to x in the root x square minus a square. This is minus sign a square. Now this integral is either right cos hyperbolic inverse x upon a, or this is log of in brackets x plus under root x square minus a square. Okay, and therefore I is equal to, or this integral is equal to 1.2 here. This 2 will come in the denominator. This is x in the root x square minus a square in bracket. Sorry, I'm writing bracket here. This is minus a square log of in bracket x plus under root x square minus a square bracket close and plus constant written by constant of integration. So this is the answer of second question. Second question we have done, that is also known as special type of integral. Okay, so these are the two special type of integrals which we calculated in the previous lectures, but one of the lectures, okay, when we discussed about hyperbolic functions, okay, trigonometric hyperbolic functions. So in that case we discussed about them, but now these are solved with the help of bypass method. Okay, that is how we have found the same answer there also and here also. This is the question second one which we have done. Now let us talk about the question number third, which is very important one. Let us talk about question number third, and for this is known as next topic. Now next topic is that there are certain integrals are given, some functions are given, those functions are separated, then they are integrated. One of them is integrated by the help of, okay, some integrals are cancelled when the functions given are separated and one of them is integrated with the help of bypass method. Then the other integral is cancelled. The other integral and a part of this and one part of the integrated one. The one part of and one part of the integral. Sorry, what I'm writing. This is integral are cancelled. What does it mean? This means, as we have written down in third question number third I'm talking about, sum of integrals dx. Within bracket there are two functions, fx plus other is derivative of this function. That means f dash x is given, okay, into dx. This is this kind of function. Now if we separate them, okay, if I separate them, then what will be the separation? This is ex into fx into dx plus this is ex of integration into f dash x into dx. Now if I integrate this function with the help of bypass method, integrating the first part, this second integral, this is first integral. Integrating the first part, So integrating, this is at I1, this is I2. Let me write I1, I2. This is I1, this is I2. Now I1 is equal to son of integrate this into fx into dx. Now this fx is for differentiation, is for integration. That means for by using eyelet method. Eyelet method, this is first function, this is second function. Integrating by integrating it. So integral of this, of this, of this. I'm sorry. Integral of this using bypass method, using BP method, we get, what is that? This is now fx as it is, first function, fx as it is, integral of ex into dx minus sign. Now ddx of fx, that means ddx of fx, first function, into integral of e raised power x into dx. This will be fx into es. You change minus sign. This is f dash x. This is f dash x into es integral into dx. What is this? This is the same function we have obtained. This is I2. Hence, I is equal to I1 plus I2 implies that this I is equal to I1 is this value. This is es into fx minus sign of integration. This is f dash x into e raised power x into dx plus sign I2 is this sign of integration es into f dash x into dx. Both are same thing. Ex into f dash x or ex into f dash x. This is f dash x into ex. So these two are cancelled out. Final answer is this one. This is ex into fx. Okay, this is the final answer. Or plus c, constant of integration, right? But this is the final answer. So one of the integral, these two integrals are cancelled out, and this was the result of the integration of the first part by bypass method. So, okay, by any method we can solve it, but this part and this last part, the second part which was given to us, are cancelled out. In this way, this kind of questions are also, we will get there, so we will solve them. Okay, from the questions given. So they are also of this type and other types also. Okay, so let me take questions now onwards. Fourth question, let me take. Now question number 4. Let us talk about. Now what is the question number 4? Let me take that question. Question number 4 is. Question number 4. What is it? Say. Question number 4 is sign of integration. Okay, ex into within bracket this is of the same that sin x plus cos x into dx. We know that differentiation of sin x is cos x. So what is the answer? Ex into sin x. Answer of this will be, if you write the answer here, it will be nothing but ex into sin x. This is the answer directly. Because we know the differentiation of sin x is cos x. The same type of question, but let me solve it. Okay, so this is equal to, let me find out that this is the result. Ex into sin x, let me separate this. Sin x into dx plus sign of integration. This is ex into cos x into dx. Now let me integrate this one. This is the first part, this is second part. By eyelet method, trigonometric function. This is exponential function is the last one. The second function. Integrating first part, this is I1, this is I2. So I1 is equal to, let me take, this is first equation. So I1 is sign of integration ex into sin x into dx. Integrating or integration of this by bypass method, by BP method is equal to, this is sin x first function. This is the first function we have taken, first function. Sin x as it is integral of ex into dx minus sin ddx of sin x into integral of ex into dx whole dx. Finally we obtain, this is sin x into ex minus sin, it will be cos x into ex, integral of ex is ex into dx. What is this? This is the same function. Okay, therefore I is equal to I1 plus I2, imply that I1 is this ex into sin x, okay, and this is plus sign, this value is also there. This is minus sin ex into cos x or cos x into ex into dx plus sin this value ex into cos x or cos x into dx. Let me write the same way as it is given. This is cos x into ex into dx. These two are similar. Final answer is ex into sin x plus constant of integration we can write, not a problem. Okay, this is constant. So this is the answer here. Final answer. This is of the question third type. These kind of questions are done. This is question number 4th we have done. Now let's talk about next question. Now question number 5th. Question number 5th, what does it say? Question number 5th is, okay, sign of integration, this x plus sin x divided by 1 plus cos x into dx. Now if I write it as x plus, this is nothing but 2 sin x by 2 into cos x by 2 divided by this 1 plus cos x is 2 cos square x by 2. I'll just talk about this is 2 cos square x by 2 or 1.2. Since cos 2 theta is equal to 2 cos square theta minus 1 equal to 1 minus 2 sin square theta, and sin 2 theta is equal to 2 sin theta into cos theta. If it is sin theta only, implies that sin theta is equal to 2 into sin 1.2 theta into cos 1.2 theta. From this formula, we have substituted this sin to sin x. Sin x means this sin theta means 2 sin x by 2 into cos x by 2. Similarly, here this is 2 cos square x by 2. Here equal to 1 plus cos 2 theta, but it is angle, single angle. This cos 2 theta will be there. Okay, so if it is already instead of cos 2 theta it is cos x only, then angle will be halved. This angle will be halved. Okay, so or let me write here. This is cos square theta equal to 1 plus cos 2 theta. Now if it is angle single 1 plus cos theta, then it will be angle half. That is half angle. Now let me divide it. So dividing them separately, this is 1.2. Let me take out, sorry, not out. In the first one, first part, this is x upon, or this is x into second square 1.2 into x. It's cos square 1.2 is here, x into second square x into dx. Plus second one, this 2 will be cancelled out. Okay, this is sin x by 2 upon 1 cos cancel out, sin x by 2 upon cos x by 2, that means tan x by 2. Okay, this is tan x by 2, son of integration dx. Okay, so this is this last part. Now this is for integration, this is for differentiation. Now if I find out integral of this by bypass method, then what is the answer here? Let me integrate. This is that I1, this is I2. No, cancel out in second case. In first case it is there. Integrating first one, I1 is equal to 1.2 sin of integration x into second square. This is 1.2 x into x. I'm integrating this by integrating this using bypass method. Using BP method, okay, bypass method, the integral of this, the integral of it will be, now this is 1.2, let me take constant common. Now this is second function, trigonometric, this is algebraic function, sorry. X here is for integral, second function, right? This is first function. X is algebraic function, first function, ilet, from ilet A T E and A T. This is trigonometric, this is algebraic. Algebraic is first function, second. Now first function as it is. Now integral of, let me say, second sphere. Okay, this is 1.2 into x into dx minus sign. Ddx of x is 1. Integral of second sphere. Okay, this is 1 into ddx of, okay, ddx of 1 into dx of second sphere 1.2 into x into dx whole dx. Now this is ddx of x here. Let me write ddx of x. That is 1. And okay, let me solve it then further. What the value of this? This is x into second square x by 2 is 10x by 2 integration 10 1.2 x upon 1.2, because after integration b divided by the coefficient of x. This is 1.2, the denominator. This is 1.2 and 1.2 cancel out, minus sign. Now in second case this 1.2 is also here. This is 1.2 into, this is 1 only,